Hello everyone. So in today's lesson, I'm going to cover similar triangles, and in a way similar triangles and congruent triangles are in the same topic, but I'm just going to tell you the difference. So in congruent triangles, two triangles are exactly the same, okay? So if you have two triangles that are exactly the same, so you can have, say, three sides being equal, right? So this will be your triple S test, right? So these are two congruent triangles. Now similar triangles are basically triangles that are similar. What that means is one triangle is a bigger version of another triangle. So say if I had a triangle that was, say, 2, 3, 4, right? The length is 2, length is 3, the length is 4. Now if I double all the sides, so I get 4, 6, 8. Now these two triangles are definitely not exactly the same because the lengths are different, but they're similar because one triangle is an enlarged version of the other triangle. So we call these similar triangles. So make sure you distinguish between congruent triangles and similar triangles. Now with similar triangles, there's also 4 tests, so make sure you remember them. Now the tests for similar triangles are a little bit different because the reasoning can be a bit more tedious, so I'm just going to go through it. So the question says, state the test used to show that the following pairs of triangles are similar. Now diagrams are not drawn to scale and all lengths are centimeters. Okay, so if you see a question where they give you the length of the 3 sides and to show that they're similar, what you can do is you can just find the ratio of all the sides. So what that means is this. So if you have those two triangles and I want to know if they're similar, then what I can do is just find the ratio of all the sides. And this is how you do it. So you just find the longer side in this triangle, so it's going to be 9, and the longer side in this triangle, which is 6. So to find the ratio, you just have to do 9 divided by 6. Okay, so I should tell you what. So you can just do PR divided by CB, right? Because this is the length PR, this is the length CB. The second longer side is what? 7.5 and then 5. So then I just do is equal to PQ over the AB. And then the last one is what? QR over the AC, right? So basically, you just have to find the ratio of all these sides, and if they're all equal to one number, then the two triangles are similar. Okay, so what's 9 divided by 6? Well, that's 1.5. 7.5 divided by 5, 1.5. 6 divided by 4 equals to 1.5. Right. So basically, what this means is all the ratio of all the sides are the equal. So we can say that these two triangles are similar because this triangle, so you can think of this triangle, is basically this triangle multiplied by 1.5. So then you can say these two triangles are similar. So if you want to actually write the proper reasoning, this is how you will do it. So now remember, when you write the reasoning for similar triangles, it's not going to be 5 steps. It's going to be a bit shorter. So for those of you that don't like writing reasoning, well, similar triangles will be easier for you. But you also remember to write the introduction. So in triangle A, you say ABC, and triangle, say, I don't know, PQR. Now what you can say is you can just write this. So PR over CB is equal to PQ over AB is equal to QR over AC, which equals to 1.5, right? So then this is your only line of reasoning, because this reason is enough to show that they're similar. So you can just say, therefore, triangle ABC is similar. Just remember, when you write there's also a special symbol for similar. It's 3 vertical lines, as you probably already know. Now remember, for congruence, it's 3 horizontal lines, right? 3 horizontal lines for congruence and 3 vertical lines for similarity. So you can say, therefore, triangle ABC is similar to triangle PQR. And the reason is 3 sides in proportion. So 3 sides in proportion. So if you want to write the shortest amount of working out, so you can just write 3 sides in proportion. Okay. So that's how you can show that two triangles are similar using the similarity proof. So you can see it's a lot easier than doing congruence because you only just need one line of reasoning, one line of introduction, and one line at the end saying that they're similar. Alright, so this is the first proof. The second one is, you have these two triangles, okay? So the second one is, it says the hypotenuse and the second side of a right angle triangle are proportional to the hypotenuse and the second side of right angle. So what that means is this. The hypotenuse, the ratio of the hypotenuses is equal to what, 14/7, and the ratio of two of the sides is also equal to 10/5. That's also equal to 2, right? So what this is, so you can kind of think of this as the RHS equivalent, but in similarity terms. So if you want to show if you want to see the reasoning behind this, you can say in triangle, so let's say MLK and triangle PNO, right? So you can say ML over the MP is equal to KL over MNO. So what that means is this side divided by this side is equal to this side divided by that side, right? So what I like to do is I always just pick the larger triangle first. So ML divided by the MP is equal to KL divided by the NO, which equals to what, 2. And then you can say angle, say LKM is equal to angle PON equals to 90 degrees. So for this one, you need 2 lines of reasoning. And then the third step, you can just say, therefore, triangle MLK is similar to triangle PNO. And the reasoning for this is going to be a bit long, but basically, so you need to say hypotenuse and side in proportion with right angle. So that's how you can write this. So I agree this reasoning is a little bit long, but I think this is the shortest way that you can write this. So this is another way to show that two triangles are similar. So you can have the hypotenuse, the ratio of the hypotenuse is equal to 2, and the ratio of the sides is also equal to 2, right? And then you also have a right angle. But remember, for part B, these kind of questions are quite rare. So this is not a common similarity problem. And then for C, if you want to just work out the ratio of the two sides, so I'm just going to pick the larger one first. So when you do these questions, it's always good to just pick the larger triangle first and start with the largest sides of each triangle. So the largest side of each triangle is what? 15 and the 5. And then the next biggest side is 9 and 3, right? Yep. Okay, so we can see that the ratio of this to this is going to be 5. 15 divided by 5 is... the ratio is going to be 3. 9 divided by 3 gives you 3, right? So we know that the ratio of the two sides are equal, and then the included angle is also the equal. So this is kind of similar to the SAS incongruency, but except this is for a similarity. So how should we write that? So we can just say in triangle ABC and triangle, say DFE. Right, we can say that DF divided by AB is equal to DE divided by the AC, which equals to what? 3, right? And then we can say angle CAB is equal to angle EDF. So these 2 lines of reasoning is enough to show that they're similar, because there's 2 sides in proportion and the included angle is equal, right? So we can say, therefore, triangle ABC is similar to triangle DEF. There should be an F. I don't know why I wrote the E, but... And the reason for that is, now the reason is going to be a bit long. So like I said, in your final step for similar triangles, the reasoning is going to be longer than your congruent triangles. So you can't just use 3 letters to represent that. So in the exam, so you can't write SAS, okay? Do not write this, because it's not really, that's only used for congruence. So what you can say is 2 sides in proportion. 2 sides in proportion, and we're saying it's 2 sides in proportion is because we know that DF over AB is equal to DE over AC. So make sure when you write the ratios, you always write the ratio You always write one side of one triangle divided by one side of the other triangle. Very important that you do that. Two sides in proportion and the included angle equal. So angle equal. So unfortunately, like I said, there's no quick way to write this reasoning. So you just need to write this, okay? Right, so hopefully this is also quite clear. Now, let's do one more. So there's actually 4 tests. And these 4 tests, you can kind of think of them as the equivalent of the congruence, but except the only difference is for the reasoning here, you need to write more words. And the last one, in my opinion, is actually the most common one, because I still remember when I did the HSC and all those practice examples. This is the one that I remember the most. And what that means is, if you can show that 2 of the angles are equal, then you can prove that they're similar. Now, the reason we only need to show 2 angles instead of 3 angles is because once we know 2 angles are equal, we know that the third one is definitely going to be equal, right? Because the third one, you can just get it by doing 180 take away the sum of the other 2 angles. So, these 2 triangles are also equal. So you can kind of think of this one as the opposite of the first one. The first one is where all 3 sides are in proportion, and the last one is where all the angles are equal. Now remember, when it comes to similarity tests, the angles, they have to be equal. The angles, so you can't have angles that are in proportion. Angles have to be equal. Sides are the ones that are in proportion. So as you can see in example B, the angles are equal, right? In C, the angles are equal. It's only the sides that are in proportion. Alright, so how do we show this? So we can say in triangle PRQ and triangle, say, WVU, right? So we can say, that angle PRQ is equal to angle what? WUV. And the reason for this is it's given. Now the other 2 angles are not equal, so then what can we do? So as you can probably tell, we already know 2 of these angles, so we can actually work out what this angle is, right? So we can say angle UWV plus 63 degrees plus 69 degrees is equal to what? 180 degrees. And the reason for that is angle sum of triangle. Right? Now, then that means angle UWV is equal to 180 take away those 2 the angles combined. So what's that? 132, so 48 degrees. Right? So then after you work out angle UWV, so you can say angle QPR is equal to UWV. Right? So you can just write therefore here because you've shown that. Okay, so now we found that 2 angles are equal, then you can just say therefore triangle PRQ is similar to triangle WVU. And the reason for this is actually the shortest one. You can just write equiangular. So this is the similarity proof which has the least amount of reasoning in your last step. What equiangular means is all the angles are equal. So the equal angles. It's just one word that will represent equal angles. Okay, so just to recap the 4 tests, I'm just going to go through it again. So there's 4 tests to show similarity. The first test is when you have the ratio of all the sides are equal. So what you can do is just start with the largest side. So in here, largest side is 9. So 9, and then your largest side in this triangle is 6. So 9 divided by 6 is equal to 7.5 divided by 5. So that's the second largest side, is equal to the third largest side, 6 divided by 4. Now, if the ratio of all these sides are equal, then they're similar. And the reason for that is 3 sides in proportion. In proportion means this, when you have one side divided by another side. The second one is probably the most rare one you'll find, and it's the one with the longest reasoning. The second one basically says if you have the hypotenuse that's in proportion, and then one other side that's in proportion, plus a right angle, they're also similar. So the reason for that is hypotenuse and side in proportion with right angle. Okay, so that's the reason for the second one. The third one basically is the SAS equivalent, but in similarity terms, is when you have 2 sides in proportion. So you have 15 and 5. 15 divided by 5 equals to 9 divided by 3. 2 sides in proportion with the included angle that's equal. Okay, so that's also a test to show similarity. And your final one is basically saying if all the three angles are equal, they're similar. So that means if you find one angle is equal, if you show that another angle is equal, then you can say they're similar. And the reason for this, you can just write it in one word, is the equiangular. So that's to give you a summary of how to prove that two triangles are similar. I'm just going to go through some of these questions and see if I need to go through any more of these. Now, question 1 just says state the test to show that the following pairs of triangles are similar. So you just need to give this reasoning. So you can say it's either equiangular, or two sides in proportion, or hypotenuse and side. So that's how you can do one. Now, make sure you do some working out for the ones to check what the ratios are. Now, example 2 says, state why the following pairs of triangles are not similar. Diagrams are not to scale and all the lengths are in centimeters. So what that means is, so what you can just do is try and work out the ratio of all the sides. And it's most likely that the ratios are not going to be equal. So I'm just going to pick this first example and demonstrate that. So I'm just going to pick the larger side first. So larger side is 15, larger side is 8. So I just do 15 on 8. Now, does that equal to the next bigger side, which is 14 and 7? So 14 and 7. Now, does 15 on 8 the equal to 14 on 7? No. So because two of the sides are not in proportion, the two triangles cannot be similar, right? So that's, and then you can check the third side. You can check the third side as well if you want to, but so the third side is equal to what? Is 12 on 6, right? Okay, so this equals to this, but it doesn't equal to 15 on 8. So remember, you need to have all three sides being in proportion to show that they're similar, right? So then that's how you can do these questions. Now, question B is a little bit tricky, and the reason it's tricky is because, as you can see, look, the ratio of the sides, 16 on 8 is equal to 14 on 7, and then you have an angle that's equal. Now, why are they not similar? If you still remember, back in congruent triangle, when you had the SAS, the angle needs to be in between the two sides, right? Now, this angle is in between the two sides, but this angle is not. So therefore, these two triangles are not similar, because this is not the included angle. Right, so that's question 2. So you can just try to find the ratios of the sides and see if they're equal. If they're not, then they're probably not going to be similar, right? Alright, so then the next question says, determine whether the following pairs of triangles are similar. So then for these questions, you need to show the steps. Now remember, because this is not a congruence question, you don't need to show 5 steps. It just really depends on the question. So for this question, it's actually even more than 5 steps. For this one, it's only 4 steps. For some of these, it's like 3 or 4. But basically, you get the main idea. Right, so I think that should be all for today. So hopefully this topic is not too challenging. I mean, from my own experience, similar triangles can be like the difficult part of doing similar triangle questions is actually writing the reasoning, because I think it's probably fairly obvious to you whether two triangles are similar. If you have two equal angles, okay, it's going to be similar, right? The hard part is actually writing out the reasoning, and that's generally the case with all geometry questions. So if you have any questions, just send me a message and I'll try my best to help you out. Thank you for listening.